Today's lesson is all about distributions. We're looking at center, shape, and spread. Before we go through those terms and look more closely into those meanings, we're going to do the do now example just to make sure that you remember how to do this on your calculator from Algebra 1. So here there's a set of data talking about snowfalls recorded for 2 seasons in a city. So this is a sample of data. We're looking for the mean and the standard deviation for this data. So this is a sample of data, so the mean is going to be expressed as x bar, and the standard deviation is going to be sx in our calculator. In order to get these values from our calculator, we're going to do our stat edit and input these values into list 1. Then we are going to do stat calc, and we are going to do the first option, 1 var stats. Then it's nice because the answers are just given to you right away, okay? So we do have a mean rounded to the nearest hundredth of 9.46 and a standard deviation of 3.85. Okay, so if you forgot what mean and standard deviation are referring to, you can look down here and we have our definitions there. So mean is the average of our data set. Okay, so some people like to say mean means average, and that's how they remember it. Okay, it's often represented by the Greek letter mu. Then standard deviation is the measure of spread or variability, and that's usually denoted by sigma. Okay, but on our calculators, if you're talking about the average of a sample set, then we use x bar. And if you're talking about standard deviation of a sample, then it's sx. Okay, if your standard deviation is really small, then your data set looks sort of like this curve here, where the peak is really high, but all of the other data falls really closely to the mean. Then the larger standard deviation option is the more spread out option here, where your peak is lower and the curve is flattened there. Okay, so now let's move on to an example where we're using the normal curve. The normal curve is a bell-shaped curve, and it is symmetric. So the bell-shaped symmetric curve we call a normal curve is really nice because if your data fits the normal curve, then we say that we have a good set of data, okay, because that means we have the mean is right in the middle, and then the rest of the data falls symmetrically on either side. So let's look at number 1 here using the normal curve. It says the lifetimes of 10,000 watch batteries are normally distributive. That just means that they fit the normal curve. Okay, now it says the mean or average lifetime is 500 days. And the standard deviation is 60 days. So we're going to sketch a normal curve that represents this distribution, and we will label the mean and 3 standard deviations. So in order to express a good normal curve, you should have 3 standard deviations on either side of the mean. So first, you want to draw your curve. Then, right in the middle, that's where your mean should lie. Okay, so for us, that mean is 500. Then we said we're going to want to have 3 standard deviations on either side of the mean. Okay, now since the standard deviation is 60 days, that means on the right-hand side, we're going to add 60 each time. Okay, so we want +1, +2, +3 standard deviations. So the first one, 560. Then 620, then 680. Okay, so I'm just adding 60 each time. Then on the other side, what we want to do is subtract standard deviations. Okay, so when we subtract 60 the first time, we have 440, then we have 380, and 320. And that's how we express our data using a normal curve there. So number 2 is basically doing the same type of process there, but you do have to go one step further because you have to actually calculate the mean and standard deviation using your calculator. So that's just the same process that we did in our do now. Okay, so this is going to be put into list 1, and you're going to be using 1 var stats. But then once you have your mean and your standard deviation, you do the same thing that we did for number 1. So now let's move on to look at the ideas of center, shape, and spread. So there are two types of distributions that we're looking at today, and that's symmetric and skewed. So the symmetric one that we've already looked into is the normal curve. So we said it's a smooth curve and it's bell-shaped and symmetric. We already went through that. The other kinds are not symmetric or normal, and those are what we called skewed. So these data sets here are skewed. Now, when we say a data set is skewed, we want to be specific. So let's actually look at these examples below. Okay, we're going to identify whether they're symmetric, skewed right, skewed left, or neither of those options. So if we look at the first data set and we draw a curve to imitate the data, we can see that this curve is basically symmetric on both sides. That means we are going to call this one symmetric. Now here, this one doesn't really fit a curve. It's more of just a rectangle. I would call that neither. Now here we have a curve that has most of its data on the left-hand side here and then a tail on the right-hand side. So when we identify which way we're skewed, we go towards the tail. So this would be considered skewed right. Then here where the tail is pointing to the left, this one is considered skewed left. Okay, so look for where the tail is to identify which way you are skewed. Now let's use all of this information we just learned and apply all the ideas to this next question in number 2. So number 2 says, have you ever noticed how sometimes batteries seem to last a long time and other times the batteries seem to last only a short time? The histogram below shows the distribution of battery life in hours for a sample of 40 batteries of the same brand. When studying a distribution, it's important to think about shape, center, and spread. Okay, so we're going to be looking at this histogram below. Notice on the vertical axes, it's saying relative frequency. Okay, that's the proportion or the percentage of the batteries that have the specific types of battery lives in reference to hours. So now let's answer the questions here. So it says, what is the width of each bar? All we have to do is look at the histogram, see how our x-axis or our horizontal axis is labeled, and we can see that each bar is 5 hours. Now, what does the height of each bar represent? Well, we said that's relative frequency. So it's the percentage of batteries that lasted the amount of hours, like whatever amount of hours you're talking about. Next, it says, would you describe the distribution of battery life as approximately symmetric or as skewed? So if you look here and you draw a curve, you can see that this is approximately bell curved. So in other words, we can say approximately symmetric. And the reason I would say that is because the data is similar on the left and right hand side. Left and right are similar. Now it says, is the mean battery life distribution closer to 95, 105, or 115 hours? Explain your answer. So mean we know is average, and in a normal curve, the average shows up right in the center. So if we look at where this data is centered about, it looks to be at about 105. So data seems to be centered at 105. Now, the next question deals with trying to figure out what the standard deviation is. So, in my opinion, the easiest way to figure out a good estimate for standard deviation is to show that there are about 3 on either side of the mean that you chose. So, if we consider 5 as an estimate of our standard deviation, then clearly we can tell that there's going to be a lot more than 3 standard deviations on either side of the mean. That means this is too small of an option to choose for our standard deviation. Now, if we look at 25 hours, well, 25 hours, that's going to leave us with less than 3 standard deviations on either side of the mean. So this is too large of a number to be a standard deviation for our data. And that's why we're going to use 10, because again, if we look at 10 as an estimate as our sample or as our standard deviation, you can see there are about 3 standard deviations on either side of the mean. Okay, so that is the easiest way to estimate what the standard deviation is, in my opinion. Okay, so 10, because then there are about 3 standard deviations on either side of the mean. Okay, so now the rest of the questions in this lesson either follow this example or examples we've done already. If you have any question, feel free to message or email me.